We are going to combine two lessons at this point. They're both alternative energy. One is alternative energy in general, and one is alternative energy specific to North Carolina. Those are actually two separate lessons on a normal basis. But for this, we're going to combine both lessons into one. This is what you should be able to do when we finish these. Critique the benefits, costs, and environmental impact of various alternative sources of energy for North Carolina. Evaluate which source of alternative energy may work best in different parts of the state and why, and examine a region, country, continent, hemisphere, and world. So we're concentrating mainly on 1 and 2 as we combine these lessons. In the previous lesson, we looked at fossil fuels, are non-renewable resources that can cause multiple types of pollution. Fossil fuels came from sedimentary rock. Also, the types that we looked at specifically were natural gas and oil, and those are drilled for. We also looked for, looked at, oh my goodness, I'm sorry, I've lost it for a moment. Coal, and coal is mined for. And we also looked at some other types of natural resources that were not exactly fossil fuels. So we looked at peat, and peat was a process before coal becomes coal. We end up with peat. And we also looked at nuclear energy as well. But if you remember in that video, we said that we're going to have to come up with different ways. We're going to run out of fossil fuels, not only as a country, but, in the U.S., but also globally, we're going to run out of fossil fuels. So we have to come up with something different. And that's where alternative energy comes into place. So alternative is something else. Okay? So if you don't have a pen, you write with a pencil. That's an alternative. So it's another choice you can use for energy. So these sources are renewable. So within our lifetime, they can be replenished. And these are also better for the environment. The types that we're going to look for alternative energy is solar, wind, biofuels, nuclear fusion, which is different from the nuclear fission that we learned earlier, because nuclear fission was a non-renewable resource, even though it was a natural resource. We're looking at fuel cells, wave power, and geothermal. Solar energy comes from the sun. This is a good thing because the sun is free. Okay? So the benefits is it's renewable. The sun is shining every day. Or the sun, even though the clouds may block it, we have the sun every day. It is also clean. There's no pollution given off, and it's quiet. Okay, in that time that I was quiet, did you hear the sun? Nope. Okay. It's also has some issues. Okay. The cost. In order to install solar panels, and these are solar panels here, you may see these are actually cover the entire side. For some, they just have smaller sections of solar panels. But installing these solar panels can be expensive. Afterwards, though, it starts to make its money back. So you put in a high investment at the beginning, and you'll start seeing the dividends, or not profits per se, but later you'll start seeing the benefits. So it may take you $1,000 to install these, but over that course of a year, you realize that you save $100 a month on electricity. So that is some savings right there. It'll end up paying for itself. It has no pollution, okay? But you also have to depend on sunny days. So what we've talked about, if those days are cloudy, you're not going to have this. Now, where is this located? Where do you normally see solar energy? Due to hurricanes, very few solar panels found near the coast because they can be damaged by wind and hail. So North Carolina has not a great bit of hurricanes, but the coastal area of North Carolina is not where you want to place these because they can be easily damaged. Let's take a quick moment to look at a video on solar energy.
Hi, I'm Lee Patrick Sullivan with Energy Now, and today I'd like to talk to you about the power of the sun. Solar power is the most abundant, most renewable resource we have. If we could collect 1/100th of 1% of the sun's energy reaching the Earth, it would be more energy than all humans use today. Just outside Yuma, Arizona is the sunniest place in the world. 90% of the year the skies are clear, and these southwest deserts have enough suitable land to supply 80% of the entire planet's current use. The sun has produced energy for billions of years and naturally energizes all of the plants on the planet. These plants give energy to animals and power the human body. This is done by a process called photosynthesis. For decades now, scientists have unlocked the secrets of how a plant creates energy through photosynthesis and can duplicate that process using modern technology and silicone. This process of creating electricity from the sun can power our homes and cities. There are two ways of capturing the power of the sun. First is photovoltaic devices, more commonly known as solar cells. They change sunlight directly into electricity. These individual cells are joined together to make solar panels. These can be placed on rooftops, calculators, and even on large-scale fields covering many acres to power cities. Solar energy systems produce no air pollutants or carbon dioxide. And because they can be placed on the top of existing buildings, they do not require extra land for power plants. Another way to capture the sun's energy is by capturing its heat. Solar thermal-electric power plants generate electricity by concentrating solar energy to boil water, which then produces steam. This steam turns a turbine, which moves a generator to produce electricity. Solar thermal-electric plants consist of fields of mirrors to reflect the concentrated sunlight onto a receiver. The receiver then collects the solar energy and converts it to heat. The production of energy from solar thermal plants work essentially the same as fossil fuel power plants. But instead of producing steam from burning fossil fuels, the steam is made by the sun. The only downside to this source of technology is that the power only exists as long as the sun is up. To help solve this problem, other forms of solar technology have been explored. Scientists are currently working on methods to store this energy for cloudy days and nighttime. One way to conquer this problem is building new power plants that combine a multitude of renewable energy sources. Using solar power and wind power and biogas could do this. When one method is not creating electricity, the other could take over. Other methods, such as storing excess power in batteries, could also be a possible future for solar technology.
This is an example of our next alternative energy is wind. Looking at the bottom of the screen, you see windmills. The windmills are high, they're very tall. We're trying to harness as much of the wind uninterrupted as we can, so that's why one of the main reasons they're there. And they have blades. These are called blades. And I want you to think of these blades right here. We don't get to see, because they're so tall, how long these blades actually are. So I want you to consider this. I want you in your head to picture a semi-truck, an 18-wheeler, a tractor-trailer, whatever your family calls those. So I want you to picture that in your head. Now, the length of these blades exceed the length of the tractor-trailer. That's their approximate length. Okay? Now, what are the benefits of wind energy? Wind is a renewable energy, so that's always good. It is also self-sustaining, which means it practically takes care of itself. As long as the wind is blowing, it is good to go. Very low maintenance. It does not give horrendous impacts to the ecosystem. Because if you notice where they are, what do you not see in this picture? Houses. Okay? So these are normally done in fields, and they do take a good bit of land to operate. So as far as cost, the initial cost is steep Okay, a high initial cost. And again, it must be taken away from the urban areas. So you have to put them out in fields. Now, the impact is it does not have any pollution. Wind is nothing is being polluted through wind energy, but it can be damaging to birds because birds go into the kind of like into the flight path. They get caught up in it, and it's not like a whole entire flock of birds. And they get caught in, and it does some damage to them. Most likely they die. I just didn't want to be morbid about it. North Carolina. As far as where do we put these in North Carolina? You will put these in the, where it's flat. So they really aren't going too well in the mountain areas unless there's some extremely flat land in the mountainous areas, what do you call it? Like a lots or something. But typically not found in the mountains, mainly found in the coast, North Carolina. Let's take a moment to look at the video on windmills on YouTube. I'm sorry, on windmills, on wind turbines.
We've all seen those creaky old windmills on farms, and although they may seem about as low-tech as you can get, those old windmills are the predecessors for new modern wind turbines that generate electricity. The same wind that used to pump water for cattle is now turning giant wind turbines to power cities and homes. Okay, have a look at this wind farm in the California desert. A hot desert next to tall mountains, an ideal place for a lot of wind. Here's another one on the windy prairies of Wyoming. Now, today's wind turbines are much more complicated machines than the old prairie windmills, but the principle is the same. Both capture the wind's energy. Okay, here's how it works. First, a wind turbine blade works sort of like an airplane wing. Blowing air passes around both sides of the blade. The shape of the blade causes the air pressure to be uneven, higher on one side of the blade and lower on the other. And that's what makes it spin. The uneven pressure causes the blades to spin around the center of the turbine. On the top, there's a weather vane that's connected to a computer to keep the turbine turned into the wind so it captures the most energy. Now the blades are attached to a shaft, which only turns about 18 revolutions a minute, and that's not nearly fast enough to generate electricity by itself. So, the rotor shaft spins a series of gears that increase the rotation up to about 1,800 revolutions per minute. And at that speed, the generator can produce a lot of electricity. So, why are wind turbines so tall? Well, the higher up you go, the windier it is. More wind naturally means more electricity. And in many cases, larger turbines can also capture wind energy more efficiently. The blades can sweep a circle in the sky as long as a football field. Now, what's really cool is that even a small wind farm, like this one in Wyoming, can generate enough electricity to power more than 9,000 homes. And larger farms can provide much more clean energy for our homes and businesses.
Now, with biofuels, this is our next one. Bio means life, fuels means energy. So what kind of energy can we get from life? And I know that's many energies, but specifically looking for powering something. Typically corn is used, and there are actually places, farms that get paid. The government pays them to grow corn for biofuels as an alternative energy. And if you take AP Environmental with me, this is one of the discussions that we have. Should you be raising the corn to feed those in poverty, or should you be raising the corn to create biofuels? We won't get into that one here in 9th grade. We'll just, or in Earth Environmental, regular at this level. So here are some benefits of biofuels. It replaces your regular fossil fuels, and it's renewable. That's a humongous benefit. The cost is cheap, and you can reuse the oils. Even your buses, some of you guys might not know this, but your buses run on biodiesel. When I taught 6th grade, we actually visited the spot in Gaston County Schools where It's the bus lot transportation area, and they explained how the biofuels are made right there on site. The impact takes lots of land to grow plants. So this becomes, again, an issue of taking land to grow these plants. That's additional space that is being used. And in North Carolina, corn is grown on the coastal plain. It's already used for ethanol. So it is what it is. We're already doing that in this area. Now I want to take a quick look at this video. How is that biodiesel made? Now as we watch this video, this is an older video. Things have changed as far as updates that have been made, but for the most part, it gives you the general information still that we need.
If your car has a diesel engine, it can run on biodiesel fuel, usually without requiring any modifications. While biodiesel and petroleum diesel are similar in energy efficiency and fuel economy, biodiesel is more eco-friendly. For starters, it can be made from what would otherwise have been waste. For example, from vegetable oil of your local fast food joint. The restaurant simply discards its used fryer oil in a receptacle out back. Every few days, a vacuum truck comes by to collect it. In its current state, the oil contains water and food particles, making it unusable for biodiesel production, so the truck transports it to a filtering plant. There, they pump the oil into a holding tank, then heat it up to draw out the water. Once they drain the water, the oil is ready to enter a multi-stage filtering process. First, the oil goes through a vibrating sieve, which strains out the larger pieces of debris. After this first filtering, the oil is already visibly cleaner. Next, it passes through a second vibrating sieve. This one has a finer mesh, therefore it catches smaller particles of debris. After the second stage, the oil looks clean, but still contains microscopic debris. So it enters the third and final filtering stage, passing through 20 ultrafine filter cloths, which trap any particles larger than 1 micron in size. A micron is about 80 times smaller than the width of a human hair. The captured debris leaves a muddy residue on the filters. That vegetable oil which once deep-fried potatoes is now ready to cook up some diesel fuel. Another source of oil for making biodiesel is beef tallow, oil derived from cow fat. Biodiesel producers typically buy tallow from facilities like this one, which specialize in cleaning cow hides for leather tanneries. Sharp revolving blades shear off the fat from the back of the hide. The fat drops onto a conveyor, which moves it into a steam injection cook tank. The tank heats the fat to a gentle boil, extracting the oil. Everything else leaves the tank and drops into a waste container. The oil moves onward, passing through a two-stage filtration process. Whether the raw material is vegetable oil or beef tallow, the biodiesel producers refer to this main ingredient as feedstock. When the feedstock arrives at the biodiesel plant, it goes into a holding tank until production time. This demonstration illustrates the production recipe. They take the feedstock and combine it with methanol, a type of wood alcohol, as well as with a catalyst, which triggers a chemical reaction. A processing unit mixes everything thoroughly while applying heat and pressure. The resulting chemical reaction produces a harmless byproduct, glycerin, a common ingredient in soaps and cosmetics. Processing consumes much of the methanol. Then they remove even more, leaving just a tiny percentage of it in the finished biodiesel. To ensure their fuel meets international regulatory standards, the plant's quality control lab tests samples from each production run. In this flammability test, They heat the fuel to 135 degrees Celsius, then apply a flame to see whether the gases ignite. If they do, they have to remove more methanol to make the fuel safe. If they don't ignite, the fuel meets international safety standards. Biodiesel costs more at the pump, but emits significantly less carbon dioxide and monoxide, and 85% fewer cancer-causing agents into the air we breathe.
Now, nuclear fusion is different from fission. Now, with fission, it's dividing, okay? And with fusion, it's putting it together. So, fuse energy drinks, for example, is an example of when they put two different things together, they fuse them together to create something else. Okay? Now, the benefits of using nuclear fission is that it is a renewable resource. And it also reduces carbon. So those are really good things that we have. Unfortunately, it is very expensive to start up. So that is definitely an issue. And getting rid of waste. When you have to get rid of the waste, it takes you have to monitor. So basically, after you've gotten everything that you wanted out of it, you have to actually monitor it for up to 10,000 years. It could still be nuclear. The impact, there's always impact or opportunities for disaster. And we have had some of those disasters with nuclear energy. One of the ones you may have not heard about is Chernobyl. That was one, and you guys might want to look that up, watch the video for that one. But it says the one that happened in your lifetime, the Fukushima, Japan, is actually one of the worst ones that happened. And I think that one is recorded as one of the worst ones in history. So actually both of those are. So you're going to watch a video on that on your own time at another time. In North Carolina, 30% of the electricity comes from nuclear plants. Okay, they are located in the Piedmont and the coastal. So let's see if we can pull back up our map. Doesn't look like we can. That's okay. Just remember where the Piedmont and coastal regions were. When we talk about nuclear disasters, we typically use the term nuclear meltdown. So here's a quick recap that was after the disaster in Japan. Had to look at the date of this one again, and they'll explain to you a little bit about what does it mean to have a nuclear meltdown.
The government now says 2 reactors are in partial meltdown and 4 more are at risk. They're warning that another explosion similar to the one we saw yesterday could be imminent. They say they're doing everything they can to contain the damage before any radiation is released. But 170,000 people have been evacuated from those areas around the facilities. Now, I want to say the word meltdown is being used a lot these days. It is a loaded and scary term, so we want to be absolutely clear about what it actually means. Ron Claiborne is here with a quick explanation of what exactly happens when a nuclear reactor melts down. Ron?
All right, Dan, let's start with a simple graphic of a nuclear reactor. Now, normally the uranium core, the potentially dangerous part of the plant, is immersed in a coolant. That is usually water. That coolant is constantly being pumped in and out to keep the core cool. When the earthquake struck in Japan, those pumps went down. The uranium core then had nothing to keep it cool, so it began heating up, boiling off that water. And if that water eventually boils away, it exposes the core, and that's when the real trouble starts. Once the temperature inside reaches 5,000 degrees, that's when you begin to have the meltdown. If the unstable uranium is disturbed in any way, it explodes, bursting through the vessel that contains it, releasing dangerous radioactive particles into the air, and that is the worst case scenario there that many fear could happen in Japan.
One more thing about nuclear fusion is that the rate at which the speed you have to get these atoms together is a very high speed, and that's another thing that could cause some damage. All right, we're going to move on. Whoopsie guys, me and this computer are not being great fans right now. Okay, hold on. Now, wave power is using the water. Okay, I guess that's the real place where you have waves, other than radio waves. But it's beneficial to North Carolina because it's renewable and it's constant. So the ocean waves are always coming. Okay, larger pool waves are always coming. And remember what we talked about. Waves can be in any large body of water. So if you have a large lake, you can have waves as well. We only really think about tides and waves referring to the ocean. But the tides and waves can be in any large body of water. So it is some downplays or some downsides is it's a high startup cost and it has lots of regulations. Because remember, technically nobody owns the ocean. So the state has to put down some regulations to ensure that at least the environment is safe. It is damaging to fish and wildlife, which means you have to create some kind of barriers in between. Think about when dams are built. And there is a separation in the water, basically. And you have some things on one side and some things on the other. So it could disturb their natural, it will disturb their natural habitat. North Carolina, if we use it, it is on the coast of North Carolina, because since we are on the ocean side, the Atlantic Ocean, that's going to be our best bet. If we don't have, it has potential. Notice it says potential, which means this is something we're really not using much of at this point, and really don't have a good startup of it. Now I'm going to say, you guys watch that video on your own. It is related to North Carolina, but I'm going to move on. To the last thing, geothermal. So with geothermal energy, geo means earth, thermal means heat, so you're looking for heat from the earth. Now it's beneficial because it's renewable and there's no carbon added to it, so that lack of pollution, has no pollution. Again, when it comes to cost, it's a high startup cost to get that going, but it is clean for the environment because again, you're just taking energy straight from the environment. Now North Carolina does not have this. In order to use geothermal heat in North Carolina, you have to have tectonic plates. Okay? Now we're thinking, well, at the mountains, we have mountains, so therefore if we have mountains, we have to have tectonic plates if we have those. Again, though, the issue becomes it has to be near a plate boundary, and we do not have access to that. All right, ladies and gents. These are some videos, again, to watch on your own at some point right now for a little added information. But for this video, for right now, that is all, video lesson, that is all I am showing you. Again, videos on your own.